Hi guys, welcome back. This is part 2 of the Two-Way ANOVA laundry detergent example we started. In this video I'm going to jump right into the hypothesis test. Now there's 3 things they want us to test in this experiment. They seem like natural things to test given our data, okay? And they seem somewhat interesting as well. First thing I would suggest is to start with the interaction test before you jump into any of the individual factors. Work on the interaction. So remember, the null hypothesis for interaction hypothesis test is that there's no interaction between what? Between, in this case, factor A and factor B are detergent and temperature, water temperature, okay? And the alternative hypothesis is that there is, or let me not hyphenate and say there is, stress that, interaction between detergent and temperature. Okay? Remember, alpha was 0.01, right? That was given to us. So we have to specify that as well. Okay? So we're going to be able to test for interaction. Next, so we'll go through that. To actually perform the test for the Two-Way ANOVA, I'm going to be providing you with computer output. So to actually conduct the test, we won't be doing it by hand. In Two-Way ANOVA, the focus is going to be much more on analyzing output that I'll provide to you that I got from a computer, okay? So from software. Alright, so let's leave that off for now. Let's state the other 2 hypothesis tests. So this is the interaction test. The next one we're going to test for, let's do laundry detergent. Let's test to see if there's a difference between the detergents. So is there a difference between detergent A, B, and C, or are they all the same? Well, that sounds like a one-way ANOVA question. And in fact, a two-way ANOVA incorporates two one-way ANOVA tests, one for each of the factors, as well as the interaction test as a bonus. Okay, so let's do detergent first. Doesn't matter, you could do water temperature. So we're saying the null hypothesis, remember, is that the mean of all the levels of the factor are equal. So mu of detergent A equals mu of detergent B equals mu of detergent C. This is saying in words that all the laundry detergents have equal mean whiteness readings. So in lay terms, they all perform equally. And the alternative, of course, you'll recall from one-way ANOVA, is that there's at least one inequality. At least one of the laundry detergents is different than the others. They could be all different, but it could just be one's different and the other 2 are the same. Okay? And alpha is going to be consistently 0.01. So that's for detergent. I'll label these in another color. Actually, let's do this. So this was for interaction. That's the first test we'll do. This was for factor B. I just happened to call, if you recall from part 1, I called detergent factor B, or just say detergent. And here I'll squeeze in at least the hypothesis test for factor A, which we called, which was water temperature, or just temperature for short. Okay, now this is another one-way ANOVA test rolled up inside the two-way ANOVA. This one pertains to water temperature, and we're asking the question, are there differences due to water temperature? Differences in what? In whiteness reading. So the null hypothesis just like in a one-way ANOVA, and just like the previous one we just did, is that no, there's no differences. That all the different types of water temperature, and there are 3, produce the same average whiteness reading. So mu of water temperature cold is equal to mu of water temperature warm is equal to mu of water temperature high. Remember, mu is the population mean, the true mean. So all 3 water temperatures have the same results, whiteness reading. Versus the alternative, which is that at least one of these pairs up here is different. It is not equal, is unequal. Okay, so they're not all the same. Alpha 0.01 again, that's again coming from up here, the level of significance. Okay, so this is the setup for performing a two-way ANOVA. It amounts to 3 separate hypothesis tests. You should understand exactly what each of these hypothesis tests is trying to do in words, as well as symbolically how I've written it here. Okay? And actually performing this, I'm going to leave for part 3, where I'm going to provide the output, which I will provide you in a two-way ANOVA example, and how to analyze that output and where to get the key information from there to actually make decisions on all these 3 hypothesis tests in turn. Okay, so keep watching part 3 continuation.